Hi there! In today's video, we're going to be talking about the Heisenberg Uncertainty Principle. Fasten your seatbelt, it's going to be a wild ride. So the Heisenberg Uncertainty Principle is a principle that many people have a little bit of trouble understanding. It's a little bit confusing sometimes, and it's completely understandable. Let's take a look at the math real quick, and then we'll back up and try to explain this using an analogy, which has real-world experimental practice to view. So the equation itself is delta x times by delta p has to be greater than or equal to h over 4 pi. Well, h here is Planck's constant, which you can find here. I hope that helps. Delta x is the position of the particle, and delta p is the momentum. Momentum is broken down into mass times velocity. So don't forget that too. It's not just velocity, it's not just a vector, it's mass times velocity. It's very important. In this case, or what we are trying to understand here, is that when we know more about the position, we know less about the velocity, the momentum, and where it's going to be. So the more that we know here, we will know less over here. That's always going to be the case. This shrinks the amount of uncertainty based on how large the object is. So if you take a bowling ball and you throw it off the edge of a building, you can predict with almost extreme certainty of exactly where it's going to be given these parameters. But when we get to the quantum size, it's a completely different story. So when we take a look at a light source and we have a slit that we want to show light through, the wider that it is, we get a beam like a laser. A wider gap here is going to create a more focused point. In short, what happens here is the more that we know about one property or value of a particle, the less we know about the other. Now, if you remember from our superposition video, I went through a little experimental phase showing you different shapes and colors of particles and being able to predict them. And the more that you knew about the particle's shape, the less you knew about its color. Well, it's very similar here. The smaller that your slit is, the less you know about where it's going to end up. And as you close that, the beam widens out. Now, imagine this is a vertical slit like this. Your light is going to spread out horizontally, perpendicular to the slit itself. It's trippy, it's crazy, really. So the more that you know about its momentum, the less you're going to know about its position. If you want to solve this equation, you need to run through it really quick. Imagine, if you will, similar to calculus. What we can do is, if we don't know the position of the particle, we can then rewrite or reformat the equation for ourselves to be that delta x is greater than or equal to h over 4 pi delta p, the momentum again, which is the same as saying h is h over 4 pi times by mass times by delta velocity. Delta velocity is going to be your change in velocity or your variable when it comes to that. When you're dealing with electrons and photons, that could be a very big number. So if you're going to try this out, start small, do a practice, and then try it for real, with real numbers. If you have any questions, please leave a comment below, and don't forget to like, share, and subscribe, and hit that little bell for notifications for future videos. I'm looking forward to seeing you next time.